Keep going.
Okay, welcome. I drew some notes just in case I forget anything. But really excited that you guys are all here, and hope you guys are also excited for this mysterious week that you have to come. I know there's not a whole lot of details because I don't think my dad and I really spent a lot of time ironing it out in terms of logistics. But I think more or less the whole robotic experience should be pretty streamlined. So that's really exciting. This question is a little abstract because I didn't give you much context. Okay, in case you don't know who I am, I'm Eric. I did 3 years of FTC back in my day. So High Definition was a team that I created with my co-captain Emma. So that's a little bit about my past. And then during my robotics experience, my dad and I started a company called BWTLink. Right, we sell a lot of door slides and a few other varying products that we designed for the context of FTC robotics. As part of another initiative that we started 3 years ago with the company, we did this thing called these design challenges. This is the third one this year, and the real reason that we have them is to give chances for students to approach solving problems in engineering inspired for the real world in the context of FTC. I don't know how well you guys are versed in this, but typically every year there's a couple teams that make these designs that everyone thinks are the best, right? And then you have this meta and everyone copies the meta as they move up ranks in the competition, right? So then it becomes a lot of, we all have the same design and then it doesn't really have a whole innovation or trying new things approach in this whole world, right? Because my 3 years, my dad and I usually try to do something pretty drastically different than everyone else. And then even when we are on the stage at Worlds and really getting into the nitty gritty of it, people are still coming up and saying hey, why would you ever do this? This doesn't work and this is terrible. You should just do it like everyone else is doing it. When you're already there, you're showing it works. So it just shows kind of the difficulty of innovating in a space like this, right? But at the same time, I think when these metas are created, it's made in the sense that I believe that in this context, this is the best way I can do this task, right? There's an old saying of don't reinvent the wheel, right? Because at the end of the day, you're all middle and high schoolers. The opportunity or the chance that you understand engineering more than people who have done this for decades or hundreds of years and stacked together, chances are pretty slim, right? So I think our design philosophy a really long time is try to find real world inspiration in designing our mechanisms, right? How do I see, this mechanism or this machine in the real world, and how can I incorporate some sort of design principle from there into my design? Because that's probably more optimized than whatever I can come up with, right? And understanding that in this sphere of an FTC competition season, it's really go, right? You don't have a whole lot of time to sit down and really think about things unless you get really good of a jump start and then you follow down the right path. So it makes sense that a lot of people want to fall into this meta because it's already shown to you, so you have minimal time to be able to be creative. But now that it's in the off season, it's nice to emphasize back to this real world inspirational design strategy and to provide that opportunity for people to really think about it. Does that kind of make sense so far? Great. So that's kind of the reasoning behind why we have these challenges. So teams from around the world can submit their attempts at these challenges, and we have some cash prizes for the teams and such and such. So, but this year, as you see in the first line, we're trying something new, which is the art of reverse engineering. That's a great reason, right? Because sometimes, with that math problem, you might not know the answer, right? But if there's an answer presented to you, you can really break it down and understand the philosophy behind why that answer works. And from there, you can learn a lot more than if you sat there redoing the same math problem for the bajillionth time, right? Kind of makes sense? A lot of skill that comes with reverse engineering. I think people a lot of times will kind of not value the opportunity and the experience you can get from this process because, hey, why should I learn from someone else if I can figure it out? And I don't know, maybe you free build your entire robot and you think, oh wow, this is a tried and true, this is great. In our context, so my dad and I put together a pretty put together CAD model of what we think robot for this past FTC season should look like, given that real world engineering principle design, right? So it should, in philosophy, completely be ready to go, right? And then the idea of this whole week is you will all really dive deep into this CAD model, understand the intricacies and how it works, how the mechanisms are working, and really understand also that real-world design strategy of like, hey, why do we do this? How do we reduce the number of motors and servos that we use in the entire robot? And why is it important to reduce weight from these actuators for it to function in our current context? Right. So that's the first part. And then now after you really understand how everything's designed, we're going to actually make it into fruition. Like we have the parts for you, so you're going to actually build it. And after that, you're going to take it to another step and improve and concept it by actually writing code so that it does what you say it will.